So this is the partial pressure quiz, and there's also a lot of stuff that's just really conversions. The first one was the easiest. You're told that hydrogen gas is collected over water at 22 Celsius, and that the barometer in the lab reads 765 torr on that day. What's the pressure of dry hydrogen? So what you had to know to do, and I think almost all of you did this correctly, is to take the pressure of the H2, and you knew that the pressure of the H2 plus the pressure of the water was going to give you your total pressure. So P total minus PH2O gives you the pressure of the hydrogen. This is the barometer reading from the lab, 765 torr, and that water pressure is a lookup. So at 22 degrees, the partial vapor pressure of water is 19.8 torr. So we get a raw answer of 745.2 torr for the pressure of the hydrogen. What would be our, well, first of all, how do we figure out the sig figs here? Nope. People want to say there are two because of that 22 Celsius. Did you use that 22 Celsius in any of your calculations? You just used it as a lookup. So everything you used had 3 sig figs. So if we were using those rules, it would be 745 torr. If we look at the fact that this is addition and subtraction, and we can go to the thing that has the fewest places behind the decimal, that would be this, it's still 745 torr. So no matter what set of rules we use, the correct sig fig answer is 745 torr. Okay, this was the easiest one on the test. Everybody got this right. Number 2 was the hardest one on the test, and I don't think anybody in this class got this one. I think I might have had one in the other class. This one was tough. So we're going to practice some more of these tomorrow. We are told that 750 milliliters of gas is collected over water at 38 degrees Celsius. If atmospheric pressure on the day of collection is 762.0 torr, what would the volume of the dry gas be at STP? You have to do multiple things here. So the first thing to do, well, the 2 things you have to do. One, you have to subtract out water pressure to get a dry gas pressure. And then you have to do a combined gas law problem. So I'm going to just start listing variables. P1, V1, T1, P2, V2, T2. And our initial volume is the first thing we're given, 750.0 milliliters. We're given a temperature, 38 degrees Celsius, which of course we have to convert to Kelvin, so that's 311 Kelvin. Our initial pressure is something that we're going to have to figure out, because P total is equal to the pressure of our gas, whatever it may be, minus the water vapor at 38. So P total minus PH2O is the pressure of our gas, and that's 762.0 minus 49.7. That's the gas pressure. We end up with an initial pressure for us of 712.3 torr. You have to do that step or you're not dealing with dry gas, and that gives you your initial pressure. We call it dry gas because we have taken out the pressure of water. So when you remove water from something, it is dry. All right, I'm going to just shrink that to the corner. Okay, now for our secondary conditions, our final conditions. STP, that gives you your temperature and pressure. What's standard temperature? 0 Celsius, so T2 is 273 Kelvin. What's standard pressure? 1 atm. And here we've already got everything in torr, so to avoid any confusion, we can just go ahead and use torr. And what we're looking for is volume. Okay, so this is the second part of this. P1 V1 over T1 equals P2 V2 over T2. You can rearrange it any way you want. Well, you can rearrange it any way you want as long as you get the correct algebraic result at the end. I've had some students who say, can I cross multiply and divide? Sure. Can I, yeah, whatever method you get there, your final rearrangement should look like this. Okay, and if your algebra is shaky, that will sink you. Okay, so we've got our final rearrangement. We're now ready to plug in. So we have all of our numbers plugged in. We're ready for a raw answer. Okay, raw answer of 617.039363 blah 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 milliliters. How many sig figs can we have here? I've got one vote. The fact that I'm not jumping to second it might give you pause. 2. Because if we look back to our original temperature, it was 38 degrees Celsius. So our original measurement there only had 2 sig figs. So our final answer would be 620 milliliters for our second volume. Yes, we did. Pardon? Because we didn't use that 22 in a calculation. That 38 goes right straight into our calculations. It's converted, but we are actually using it to multiply. So it has to inform our sig figs. These kind of questions are the toughest ones because you have to do 2 different things. You have to find your P1 and then you have to use it. When you take the quiz test quest for this chapter, there will be one like that. So where you have to do combined gas law and subtracting out partial pressure. Okay, the back, these are actually much easier. They're really just conversion and addition. So you have, what you have to know to do these is that P total is equal to P1 plus P2 plus P3. And I ask you specifically for the answer in torr, so you do have to convert everything to torr. I've had a few people throughout the course of this like convert everything into ATMs, then convert it back into torr. Every time you do a conversion, you risk losing a little bit of information. So the fewer conversions you can do, the better. That's like, what was the document I remember somewhere reading something, or an example of something being read, and it was horrible. It was really hard to understand. And they said, oh, so it was translated from the original French into, Russian, and then translated to German, and then translated back to French. And it was incomprehensible. It was, the more times you translate, the more possibilities for error there are. So translate or convert as few times as possible. So here we were given P total as 3.2 ATM, so we're going to have to convert that one, and 1 ATM is 760 torr, so that gives us 2,432 torr. P1 was given to us in torr, and that's 806 torr. And P2 was given to us as 81.9 kilopascals. We have to convert that one, and we know that 760 torr are equal to 101.325 kilopascals. So that gives us 614.3005181 torr. Well, now we've got everything together. We can solve. We're looking for the pressure on P3, so we can rearrange to solve for that. So we have our rearrangement. We have everything plugged in, and we're going to get a raw number of 1,011.699482 torr for P3. How many sig figs can we have? 2. So the only way to correctly express that with 2 sig figs is 1.0 times 10 to the third torr. It's the only way to express it correctly. Questions, comments on that one? These aren't too bad because they're just a conversion, an addition and subtraction. The things to watch out for are just, not over-converting. So let's look at 4. Again, for this one, it's the same exact kind of problem. You just have to know that your total pressure, though here you were given actual specific gases, is equal to the pressure of your nitrogen plus the pressure of your oxygen plus the pressure of your CO2. And so we're solving for CO2, P total minus the pressure of the nitrogen minus the pressure of the oxygen gives you the pressure of the CO2. All right, so we do have to do some conversions here. Our total pressure was given to us in torr at 780. And we were asked for the answer specifically in ATMs, so that's what we got to do. And that gives us 1.026315, blah, blah, blah. The pressure of our nitrogen was given to us in kilopascals because somebody just loves a good joke. 26.9 kilopascals, 101.325 kilopascals is 1 ATM, so we get 0.2654, blah, blah, blah. And thank goodness the pressure of our oxygen was already given to us in ATMs, 0.457 ATMs, so we don't have to do anything with it. So now that we have all of our conversions, we can just do our subtraction. And of course you can also, I had a few people who put these in parentheses, that the total pressure is minus the sum of the pressure of the other two gases is equal to the final gas. And that's fine too. I don't care. That's algebraically legal. You can do it. So without writing all of these down, what we get as a raw answer is 0.30383343 ATMs is the pressure of the CO2. Be real careful not to take sig figs until the very last bit. So don't sig fig everything in the first steps. And you guys are pretty good at that at this point. So how many sig figs can we have? Two. Because that 780 didn't have a decimal after it. So this becomes 0.30 ATMs for a final answer. Okay, tomorrow we will grade the homework, but we will probably also do a little bit of going over problems like number 2, because I feel like people need a little bit more help with that. There are additional practice problems just in the homework. The mixed review is full of good practice problems. If you want to do some extras, you know you can check answers. So if you have homework and you want to check answers so that you see if you're doing it right, please do that. We'll grade the homework and kind of work back on some of the mixed problems. And Monday will be your quiz/test. So I'm anticipating about 10 multiple choice problems and one of each kind of the other problems. So pretty short and sweet, and then we go into a little bit of stoichiometry, and then we get to do crystallines. So that's fun. All right, that's it.